On May 27, 1941, British naval forces engaged the German battleship Bismarck in the North Atlantic Ocean. The engagement lasted approximately 90 minutes. During this time, British battleships HMS King George V and HMS Rodney fired over 400 shells at Bismarck. British cruisers and destroyers launched numerous torpedoes. The concentrated firepower represented one of the most intensive naval bombardments in maritime history. Despite this overwhelming attack, Bismarck remained afloat until the German crew scuttled the ship. When oceanographer Robert Ballard discovered Bismarck's wreck in 1989, at a depth of 4,190 meters, examination of the hull revealed that the ship's armor had largely held. The underwater structure showed minimal penetration damage. British shells had destroyed the superstructure and killed most of the crew, but had failed to create catastrophic hull breaches that would have caused rapid sinking. This video examines the engineering of Bismarck's armor system, the circumstances of the final battle, and the technical analysis that explained why 400 direct hits could not sink the ship through conventional means. The Treaty of Versailles, signed on June 28, 1919, imposed severe restrictions on German naval capabilities. Article 181 limited Germany to 6 battleships displacing no more than 10,000 tons. Construction of submarines was prohibited. Naval aviation was forbidden. The German High Seas Fleet was surrendered to Allied powers and subsequently scuttled at Scapa Flow. These restrictions remained in effect throughout the 1920s. Germany maintained a small coastal defense force consisting of pre-dreadnought battleships and light cruisers. Naval construction was minimal. The German Navy, known as the Reichsmarine, was effectively eliminated as a significant military force. The situation changed in the 1930s. On January 30, 1933, Adolf Hitler became Chancellor of Germany. The new government rejected Versailles Treaty limitations and initiated rearmament programs across all military branches. For the Navy, this meant planning and constructing modern warships that would restore German naval power. On June 18, 1935, Germany and Britain signed the Anglo-German Naval Agreement. This treaty permitted Germany to build a fleet up to 35% of the Royal Navy's tonnage. For capital ships, this meant Germany could construct battleships up to 35,000 tons displacement, the limit established by the Washington Naval Treaty of 1922 and London Naval Treaty of 1930. German naval planners immediately began designing new battleships. The design process focused on creating ships with maximum combat effectiveness within treaty limitations. However, German designers intended to exceed treaty limits covertly. The final designs would substantially exceed 35,000 tons displacement, while official documentation would report lower figures. The Bismarck-class battleships were designed by German naval architects working at the Kriegsmarine Construction Office in Berlin. The lead designer was Wilhelm Hardeler, who had extensive experience with German battleship construction dating to World War I. The design team included specialists in armor protection, propulsion systems, weapons integration, and naval architecture. The design philosophy emphasized survivability and armor protection over speed and armament. While other nations' battleships prioritized firepower or speed, German designers focused on creating a ship that could absorb significant damage and continue operating. This approach reflected lessons from World War I, where German ships had demonstrated superior damage resistance compared to British counterparts. The final specifications for Bismarck were as follows. Dimensions: length overall, 251 meters. Beam, 36 meters. Draft, 9. 3 meters fully loaded. Displacement: standard displacement, 41,700 tons. Full load displacement, 50,300 tons. These figures exceeded treaty limits by approximately 15,000 tons. German authorities reported displacement as 35,000 tons in official documentation provided to other nations. Armor protection: main belt armor, 320 mm maximum thickness. Deck armor, 120 mm. Turret face armor, 360 mm. Conning tower armor, 350 mm. The armor scheme used Krupp cemented armor, which was harder and more resistant than armor used by other navies. The belt armor was inclined at 20 degrees from vertical, which increased effective thickness against incoming shells. Armament: main battery, 8 38cm SK C-34 guns in 4 twin turrets. Secondary battery, 12 15cm guns in 6 twin turrets. Anti-aircraft armament, 16 10.5cm guns, 16 37mm guns, 12 20mm guns. The 38cm guns fired 800 kg armor-piercing shells with a muzzle velocity of 820 meters per second. Maximum range was 36,520 meters. Rate of fire was approximately 2.5 rounds per minute per gun. Propulsion: 12 Wagner high-pressure boilers, 3 Brown Boveri geared steam turbines. Total power output: 150,070 shaft horsepower. 3 propeller shafts. Performance: maximum speed: 30.8 knots, 57 kilometers per hour. Range: 8,870 nautical miles at 19 knots. Fuel capacity: 7,400 tons of oil crew. Officers: 103 enlisted personnel, 1,962. Total: 2,065. These specifications made Bismarck one of the most powerful battleships in service in 1941. The combination of heavy armor, powerful armament, and long range created a ship capable of operating independently in the Atlantic against British convoy routes. Construction of Bismarck began on July 1, 1936, at the Blohm & Voss shipyard in Hamburg, Germany. The shipyard had extensive experience constructing large warships and possessed the facilities necessary for building a battleship of Bismarck's size. The construction process followed standard shipbuilding procedures of the era. The keel was laid in a construction slip. Steel frames were erected to form the hull structure. Steel plates were welded and riveted to the frames to create the hull shell. Internal compartments were constructed according to design specifications. Systems installation followed hull completion. The construction timeline proceeded as follows: July 1, 1936, keel laid February 14, 1939. Ship launched August 24, 1940. Ship commissioned into Kriegsmarine. Total construction time was approximately 50 months. This timeline was comparable to construction times for similar battleships built by other nations during the same period. The launch ceremony on February 14, 1939, was attended by Adolf Hitler and other high-ranking German officials. Dorothea von Löwenfeld, granddaughter of Otto von Bismarck, performed the christening. The ship was named after Otto von Bismarck, the Prussian statesman who unified Germany in 1871. After launching, Bismarck was moved to fitting out berths where weapons, armor, and internal systems were installed. The 8 38cm guns were manufactured by Krupp and transported to Hamburg for installation. Armor plates manufactured at Krupp Steelworks in Essen were shipped to the shipyard and installed on the hull. Electronic systems, fire control equipment, and propulsion machinery were integrated into the ship's structure. Total construction cost was approximately 196.8 million Reichsmarks. This figure represented a substantial portion of German naval construction budgets for the period. For comparison, a Type 7 U-boat cost approximately 2 million Reichsmarks, meaning Bismarck's construction cost equaled approximately 98 submarines. Following commissioning in August 1940, Bismarck underwent sea trials in the Baltic Sea. These trials tested propulsion systems, weapons, steering, and general seaworthiness. Trials continued through spring 1941. The ship was declared operationally ready in May 1941. The main armor belt extended along the waterline for approximately 70% of the ship's length. The belt protected the machinery spaces, magazines, and other vital areas. The armor consisted of 3 layers. External layer, 145 mm of hardened steel. Main layer, 320 mm of Krupp cemented armor. Internal layer, 45 mm of hardened steel. Total thickness at the thickest section, 510 mm. The belt was inclined inward at approximately 20 degrees from vertical. This inclination increased effective thickness. A shell striking the belt at perpendicular would encounter more armor thickness due to the angle. The inclination also increased the likelihood of shells glancing off, rather than penetrating. Krupp cemented armor was produced through a face-hardening process. The face of the armor plate was carbonized and heat-treated to create an extremely hard surface layer. The backing remained tougher and more ductile. This combination allowed the armor to resist penetration through the hard face while preventing shattering through the tough backing. German Krupp-cemented armor was approximately 10–15% more effective than British or American armor of equivalent thickness. A 320mm Krupp plate provided protection equivalent to approximately 350–370mm of British armor. Deck armor protected against shells falling at steep angles, typical of long-range engagement. The deck armor consisted of 3 layers. Weather deck, 50mm main armored deck, 120mm, splinter deck, 20mm. The main armored deck was positioned relatively low in the ship's structure, approximately at the waterline level. This placement meant that shells penetrating through the side armor would still need to penetrate the armored deck to reach vital spaces below. The deck armor could resist 380mm armor-piercing shells fired at ranges exceeding 18,000 meters. At these ranges, shells followed high trajectory arcs and struck deck armor at steep angles. Most contemporary battleships had thinner deck armor and were vulnerable to plunging fire at long ranges. The underwater protection system defended against torpedoes and underwater explosions. The system consisted of multiple compartments arranged between the outer hull and the inner hull. Outer hull, 45mm. Void space, 2 meters wide. Torpedo bulkhead, 45mm liquid-filled compartments. Inner torpedo bulkhead, 45mm. Additional void space, inner hull, 45mm. When a torpedo exploded against the outer hull, the blast energy propagated through the system. The void spaces absorbed and dispersed energy. The liquid-filled compartments absorbed additional energy through compression and venting. By the time the blast reached the inner hull, most explosive force was dissipated. The system was designed to withstand torpedoes with warheads of approximately 300 kilograms of explosive. British aerial torpedoes typically carried warheads of 176 kilograms. British ship-launched torpedoes carried warheads of 340 kilograms. The protection system provided adequate defense against most contemporary torpedoes, though heavy ship-launched torpedoes could potentially cause damage if multiple hits occurred in the same area. The ship's interior was divided into 22 main watertight compartments. Each compartment could be sealed by watertight doors. Flooding of one compartment would not spread to adjacent compartments if doors were properly closed. The engineering spaces were particularly well compartmentalized. There were 3 separate boiler rooms and 2 separate engine rooms. Damage to any single space would not disable the entire propulsion system. If one boiler room flooded, the remaining boilers could maintain reduced power. If one engine room was damaged, the other engines could maintain propulsion. This redundancy was critical for damage control. Most battleships had 2 or 3 main engineering spaces. Bismarck effectively had 5 separate spaces, each capable of independent operation. This arrangement significantly improved survivability against below-waterline damage. By May 1941, German Naval Command planned to deploy Bismarck in commerce raiding operations against British convoy routes in the Atlantic Ocean. The operation was designated Rheinübung, Rhine Exercise. The strategic objective was to disrupt British supply lines. Britain depended on imports of food, fuel, and war materials transported by merchant ships across the Atlantic from North America. German surface raiders could potentially sink dozens of merchantmen before being intercepted by British naval forces. Even temporary disruption of convoy routes would strain British resources and potentially affect Britain's ability to continue the war. The operation plan called for Bismarck and heavy cruiser Prinz Eugen to break out from German-controlled waters into the Atlantic Ocean. The ships would transit through the Denmark Strait between Iceland and Greenland, then proceed south into the Atlantic shipping lanes. Once positioned, they would attack merchant convoys while avoiding engagement with British capital ships when possible. Fleet Commander Admiral Günther Lutyens commanded the operation. Lutyens was an experienced officer who had previously commanded successful commerce raiding operations with battleships Scharnhorst and Gneisenau. He was considered cautious and professional. The operation faced several challenges. British naval forces significantly outnumbered German forces. The Royal Navy maintained multiple battleships, aircraft carriers, cruisers, and destroyers in home waters and the Atlantic. If British forces located Bismarck and Prinz Eugen, concentrated attacks could overwhelm the German ships through superior numbers. Additionally, the breakout route through the Denmark Strait was monitored by British patrols. The strait was only approximately 290 kilometers wide. British cruisers equipped with radar patrolled the area continuously. Detection during transit was likely. German Naval Command assessed these risks as acceptable. Bismarck's armor protection would allow the ship to survive engagement with individual British capital ships. Bismarck's speed would allow escape if confronted by superior forces. The potential damage to British supply lines justified the operational risks. On May 18, 1941, Bismarck and Prinz Eugen departed Gotenhafen, modern Gdynia, Poland, and proceeded through the Baltic Sea toward Norway. The German ships transited through the Kattegat Strait between Denmark and Sweden on May 19. Swedish intelligence observers noted the passage and reported to Swedish Naval Command. Swedish authorities informed British intelligence through established channels. British naval intelligence received reports of Bismarck's movement on May 20. The implications were immediately clear. Bismarck was likely preparing to break out into the Atlantic. If this occurred, British convoy routes would be threatened by the most powerful battleship in the German fleet. British forces began deployment. The battleship HMS Prince of Wales and battle cruiser HMS Hood were ordered to intercept. Both ships were stationed at Scapa Flow, the primary British naval base in Scotland. They departed on May 22, heading northwest toward the Denmark Strait. Additional forces were mobilized. Battleships HMS King George V and HMS Rodney were deployed. Aircraft carrier HMS Victorious was ordered to support operations. Cruisers HMS Suffolk and HMS Norfolk were already patrolling the Denmark Strait. Multiple destroyer squadrons were positioned along potential transit routes. On May 21, Bismarck and Prinz Eugen anchored in Korsfjord near Bergen, Norway. The ships refueled from the tanker Volin. British reconnaissance aircraft photographed the German ships in the fjord, confirming their location and composition of the force. Admiral Lutyens faced a decision. British knowledge of the operation meant that surprise was compromised. British forces would be positioned to intercept during the Denmark Strait transit. The operation could be aborted and the ships returned to German ports. Alternatively, the operation could proceed despite British awareness. Lutyens decided to continue. Returning to port would accomplish nothing and would appear as retreat. The mission objectives remained valid. Bismarck's capabilities provided reasonable probability of success even against prepared opposition. On May 21 at 1900 hours, Bismarck and Prinz Eugen departed Norway and proceeded north toward the Denmark Strait. Estimated transit time to the strait, 36 hours. The Denmark Strait separates Iceland from Greenland. The navigable width varies from approximately 290 kilometers in the south to 480 kilometers in the north. Ice fields from Greenland often extend into the strait, reducing the effective width. The strait represented the most direct route from Norway to the Atlantic, but was also the most dangerous due to confined waters and British patrols. On May 23 at 1922 hours, HMS Suffolk detected Bismarck and Prinz Eugen on radar at range of approximately 23,000 meters. Suffolk was a County-class heavy cruiser equipped with Type 284 radar. The radar allowed detection in low visibility conditions that would prevent visual observation. Suffolk's captain immediately transmitted contact reports to British command while maintaining position astern of the German ships. HMS Norfolk, stationed nearby, also detected the German force and began shadowing. Both cruisers maintained distance of 20,000–25,000 meters beyond effective gun range while transmitting continuous position updates. Admiral Lutyens was aware that British cruisers were shadowing. Bismarck's radar operators detected British radar emissions. The German ships increased speed to 28 knots, attempting to outdistance the shadowing cruisers. However, British radar allowed Suffolk and Norfolk to maintain contact despite reduced visibility. The shadowing continued through the night of May 23–24. British cruisers transmitted regular updates. Hood and Prince of Wales received these transmissions and adjusted course to intercept. By 0200 hours on May 24th, Hood and Prince of Wales were approximately 160 kilometers from Bismarck's position, closing at combined speed of approximately 55 knots. At 0535 hours on May 24th, lookouts aboard HMS Hood visually detected Bismarck and Prinz Eugen at range of approximately 31,000 meters. The German ships were silhouetted against the lighter eastern horizon. British ships approaching from the southwest were more difficult to observe against the darker western sky. Vice Admiral Lancelot Holland commanded Hood and Prince of Wales. Holland immediately ordered both British ships to turn toward the Germans and increase speed to close range. British doctrine called for engagement at medium ranges where British guns would be most effective and German guns less effective. At long ranges, shells followed high arcing trajectories and struck deck armor, which was Hood's weakness. Hood's deck armor ranged from 25 to 75 millimeters thickness. This was inadequate against 380 millimeter shells at long range. If German shells penetrated Hood's deck and reached the magazines, catastrophic explosion could result. Holland understood this vulnerability and attempted to close range quickly. At 0552 hours, at range of approximately 23,000 meters, Hood opened fire. 8 381mm guns fired. The first salvo fell near Prinz Eugen, which German observers had initially mistaken as the leading ship. British fire control had made the same identification error. 1 minute later, Prince of Wales opened fire with 10 356mm guns. At 0555 hours, Bismarck received permission to return fire. The first salvo was aimed at Hood. German fire control was accurate. The first salvo straddled Hood with shells falling both short and over. The second salvo, fired at 0556, scored at least one hit on Hood's boat deck. Range decreased rapidly as both forces approached each other. By 0558, range had closed to approximately 18,000 meters. Both sides were scoring hits. Hood had taken several hits from Bismarck and Prinz Eugen. Fires had started on Hood's boat deck. Prince of Wales had also scored hits on Bismarck, causing flooding in forward compartments and fuel contamination. At 0600 hours, Bismarck fired her fifth salvo. The shells followed a trajectory time of approximately 23 seconds before impact. At least one shell, possibly two, struck Hood's deck near the aft main magazines. The 380mm armor-piercing shell penetrated through the 50mm deck armor. The shell continued downward through internal decks and structures until reaching the aft 381mm magazine. The shell's base fuse detonated the bursting charge inside the magazine. The magazine contained approximately 100 tons of cordite propellant in bags. Additional shells were stored in ready racks. The temperature and pressure from the shell's explosion ignited the cordite. The subsequent explosion was catastrophic. The aft magazine detonation propagated forward through connecting spaces to additional magazines. Multiple magazines detonated in rapid succession. The explosions broke Hood's keel and separated the ship into sections. The forward section sank immediately. The aft section remained afloat briefly before also sinking. Total time from explosion to complete sinking, approximately 3 minutes. Of Hood's crew of 1,418 officers and men, 3 survived. The survivors were ordinary signalman Ted Briggs, able seaman Bob Tilburn, and midshipman William Dundas. All 3 had been stationed on the bridge or compass platform and were thrown clear by the explosion. They were rescued by HMS Electra several hours later. The destruction of Hood had immediate tactical effects. Prince of Wales was now engaged against 2 German ships without support. Prince of Wales was newly commissioned and experiencing mechanical problems with her main armament. Several gun turrets had malfunctioned. The ship could only fire with partial battery. Captain John Leach commanded Prince of Wales. Observing Hood's destruction and recognizing his ship's vulnerabilities, Leach ordered disengagement at 0613 hours. Prince of Wales turned away and laid smokescreen while retreating. German ships did not pursue extensively. The Battle of the Denmark Strait had lasted approximately 20 minutes. British losses: HMS Hood destroyed, 1,415 dead. HMS Prince of Wales damaged, 7 dead. German losses: no ships lost. Bismarck sustained 3 hits causing flooding and fuel contamination, but remained combat effective. Prince Eugen sustained no significant damage. The battle demonstrated Bismarck's effectiveness. The ship had destroyed the Royal Navy's most famous battleship in minutes. British naval prestige suffered severe blow. However, the hits from Prince of Wales had caused problems that would affect Bismarck's operational capabilities. The 3 shells from Prince of Wales that struck Bismarck caused varying degrees of damage. Hit number 1, one 356mm shell struck below the waterline in the forward section, penetrating the hull near frame 21. The shell created a hole approximately 2 meters by 1 meter in the port side. Water entered compartment 21, causing flooding. Additionally, fuel oil from ruptured tanks leaked into compartment 20. Approximately 1,000 tons of fuel oil was lost or contaminated. The flooding was contained by watertight doors. However, the damage caused the bow to settle approximately 3 degrees down by the head. At high speeds, water washed over the bow, causing additional problems and reducing maximum speed from 30.8 knots to approximately 28 knots. Hit number 2. One shell struck the forecastle deck but caused minimal damage. The shell may have been a dud that failed to detonate. Hit number 3. One shell struck amidships, penetrating through several decks but failing to detonate. The shell passed through the ship without exploding and exited from the starboard side. Damage was limited to structural holes. Total damage assessment: Bismarck remained combat capable but with reduced speed and reduced fuel capacity. The forward flooding could not be repaired at sea. The fuel contamination reduced operational range. Maximum speed reduction affected ability to escape if pursued. Admiral Lutyens evaluated the situation. The original operation plan called for continuing into the Atlantic to raid convoy routes. However, with reduced fuel and speed, this objective was no longer feasible. If Bismarck encountered British battleships while damaged, the outcome might be unfavorable. Lutyens made the decision to abort the Atlantic raid and proceed to Saint-Nazaire, France, for repairs. Saint-Nazaire had dry dock facilities capable of handling battleships. From Saint-Nazaire, Bismarck could be repaired and potentially resume operations. Prince Eugen would separate and continue independent operations. At 1400 hours on May 24th, Prince Eugen separated from Bismarck and proceeded independently toward the Atlantic. Bismarck turned southeast toward France. Distance to Saint-Nazaire, approximately 2,800 kilometers. Estimated transit time at 20 knots, approximately 75 hours. British forces were already converging to intercept. Following the Battle of the Denmark Strait, British Admiralty ordered all available naval forces to pursue and sink Bismarck. The directive from Prime Minister Winston Churchill was explicit. Sink the Bismarck. British forces deployed included battleships HMS King George V, 10x 356mm guns, HMS Rodney, 9x 406mm guns, aircraft carriers HMS Victorious, HMS Ark Royal Battlecruiser, HMS Renown cruisers, HMS Norfolk, HMS Suffolk, HMS Dorsetshire, HMS Edinburgh, HMS Sheffield destroyers, approximately 20 ships. These forces converged from multiple directions. King George V and accompanying destroyers approached from the northwest. Rodney, which had been escorting a convoy, detached and steamed at maximum speed to intercept. Renown and Ark Royal operated from Gibraltar. Force H from Gibraltar included Ark Royal, Renown, and cruiser Sheffield. Throughout May 24th, HMS Suffolk and HMS Norfolk maintained radar contact with Bismarck. The German ship could not shake the shadowing cruisers. British radar technology allowed tracking even in poor visibility and darkness. At 22:30 hours on May 24th, 9 Fairey Swordfish torpedo bombers from HMS Victorious attacked Bismarck. The Swordfish were obsolete biplanes with maximum speed of approximately 220 kilometers per hour. However, they carried 450mm aerial torpedoes. The attack occurred in poor visibility and rough seas. Bismarck's anti-aircraft guns engaged the slow-moving biplanes. German gunners had difficulty tracking the aircraft due to low speed and maneuvering. One torpedo struck Bismarck on the starboard side amidships. The underwater protection system absorbed the explosion with minimal damage. Minor flooding occurred but was quickly controlled. The torpedo strike demonstrated that British forces had air attack capability and would continue pursuing. However, the damage was negligible. Bismarck's torpedo defense system had functioned as designed. On May 25th, at 03:06 hours, British radar contact was lost. Suffolk lost Bismarck on radar for approximately 31 hours. During this period, British forces did not know Bismarck's precise location or course. Admiral Lutyens transmitted a long radio message to German Naval Command at 0900 hours on May 25th. The transmission lasted approximately 30 minutes and reported battle results and current status. British direction-finding stations intercepted the transmission. By triangulating signals from multiple stations, British intelligence determined Bismarck's approximate position and deduced that the ship was heading southeast toward France, rather than west toward mid-Atlantic. This information allowed British forces to redirect pursuit. By late May 25th, British ships were positioned to intercept Bismarck before reaching France. However, Bismarck maintained substantial lead. At current speeds, the German ship would reach air cover from French bases before British battleships could intercept. The pursuit now depended on slowing Bismarck through air attacks. On May 26, Force H from Gibraltar, HMS Ark Royal, HMS Renown, HMS Sheffield, was approximately 160 kilometers from Bismarck's estimated position. Ark Royal prepared to launch torpedo bomber strikes. At 14:50 hours, 15 Fairey Swordfish launched from Ark Royal. Due to poor coordination, the aircraft initially attacked HMS Sheffield, which was shadowing Bismarck. The torpedoes were equipped with magnetic detonators that malfunctioned, causing premature detonation or running too deep. No hits were scored on Sheffield. The Swordfish returned to Ark Royal, were rearmed with torpedoes using contact detonators, and launched again at 19:10 hours. This time, 15 Swordfish located Bismarck and attacked from multiple directions. The attack occurred in deteriorating weather conditions. Wind speed exceeded 50 kilometers per hour. Waves were 3 to 4 meters high. Visibility was poor. These conditions made flying difficult, but also made German anti-aircraft fire less effective. Bismarck's anti-aircraft guns engaged the attacking aircraft. The 105mm, 37mm, and 20mm guns created heavy defensive fire. Several Swordfish sustained damage, but all survived the attack. Multiple torpedoes were launched, most missed. Several torpedoes struck the armored belt and caused minimal damage. The underwater protection system absorbed these hits as designed. However, at approximately 20:56 hours, one torpedo struck Bismarck's stern on the port side near the rudders. The torpedo explosion occurred in an area with less armor protection than the main belt. The stern had thinner plating due to structural considerations. The explosion jammed the port rudder at 12 degrees to port and damaged the steering machinery. Damage control teams attempted repairs. Divers were sent to examine the rudders underwater. They reported that the port rudder was jammed and could not be moved manually. The steering machinery was damaged beyond shipboard repair capability. Attempts to cut away the damaged rudder failed due to sea conditions and inadequate equipment. With the rudder jammed to port, Bismarck could only steam in large circles or proceed on limited courses by using engines at differential speeds. This method reduced speed to approximately 8 to 10 knots and was not sustainable for long distances. Effective steering control was lost. Admiral Lutyens transmitted to German Naval Command at 2140 hours. Ship no longer maneuverable. We will fight to the last shell. Long live the Führer. The message indicated that Lutyens understood Bismarck's situation was terminal. Without steering, the ship could not evade British battleships. Without maneuverability, the ship could not escape. Combat with superior British forces would be unavoidable. The outcome was predetermined. German Naval Command ordered destroyers and submarines to assist Bismarck, but these forces were too distant to arrive before British battleships engaged. Luftwaffe aircraft were ordered to provide air cover, but weather conditions prevented large-scale operations. During the night of May 26-27, British destroyers made torpedo attacks against Bismarck. Several hits were scored, but caused no additional critical damage. The attacks prevented German repair efforts and exhausted the crew. Through the night, Bismarck slowly wallowed in heavy seas, unable to steer, waiting for the final battle at dawn. At 06:15 hours on May 27th, Lookouts aboard HMS Rodney sighted Bismarck at range of approximately 23,000 meters. HMS King George V was positioned nearby. Both British battleships were accompanied by cruisers HMS Norfolk and HMS Dorsetshire, plus multiple destroyers. Bismarck's tactical situation was hopeless. The ship could not steer effectively. Speed was reduced to approximately 7 knots. British battleships had numerical superiority in guns. King George V's 10 356mm guns, plus Rodney's 9 406mm guns, against Bismarck's 8 380mm guns. Additionally, Bismarck's forward fire control position had been damaged during the night destroyer attacks. The main fire control director in the foretop was inoperable. Secondary fire control positions would have to be used, reducing accuracy. Ammunition supply had been disrupted by flooding in forward magazines. The forward turrets could access limited ammunition. At 08:47 hours, HMS Rodney opened fire from range of 23,000 meters. King George V opened fire moments later. Bismarck returned fire at 08:50 hours. The engagement proceeded as follows. 0847-0900, long-range firing. British shells fell around Bismarck. Bismarck's return fire was less accurate due to fire control damage. Several British hits scored on Bismarck's superstructure. The forward main director was destroyed. The foretop was hit repeatedly. 900-0922. British ships closed range to approximately 15,000 meters. Rate of fire increased. Bismarck continued returning fire, but accuracy decreased as fire control positions were destroyed. Multiple hits from both British battleships began destroying Bismarck's gun turrets. At 09:02 hours, one 406mm shell from Rodney struck Bismarck's forward superstructure, destroying the bridge and killing most command personnel, including likely Captain Lindemann. His exact time of death is uncertain, but probably occurred during this phase. 0920-1000. Range decreased to 8,000-12,000 meters. This was point-blank range for battleship guns. British gunners could visually aim at Bismarck without fire control computers. Both British battleships fired continuously. Bismarck's turrets were systematically destroyed. 0920, turret Bruno, forward, knocked out 0927, turret Dora, aft, knocked out 0931, turret Anton, forward, knocked out 0931, turret Caesar, aft, knocked out by 0931, all main battery turrets were disabled. Bismarck could no longer return effective fire. 1000 to 1036, British ships continued firing at helpless target. Bismarck's superstructure was completely destroyed. All above-deck structures were demolished. The ship was burning throughout. However, the armored hull remained largely intact. British shells were destroying soft structures, but not penetrating the main armor belt or citadel sufficiently to cause rapid sinking. Shell expenditure. HMS Rodney fired approximately 380 shells from main battery, 406mm, plus numerous secondary battery shells. HMS King George V fired approximately 339 shells from main battery, 356mm, plus secondary battery shells. HMS Norfolk, cruiser, fired approximately 527 shells from 203mm guns. HMS Dorsetshire fired numerous shells from 203mm guns. Exact count uncertain. Total main battery shells, over 700 shells from battleships alone. Including cruiser shells and destroyer torpedoes, total ordnance delivered exceeded 800 individual weapons. The overwhelming majority of these shells hit Bismarck. At ranges of 8,000-12,000 meters, missing was nearly impossible. Hit percentages exceeded 90% for most of the engagement. Despite this massive bombardment, Bismarck remained afloat. The hull was intact. The ship was listing to port and settling, but not sinking rapidly. British gunners had destroyed everything above the waterline, but had failed to create catastrophic breaches in the armored citadel. At 10:15 hours, Admiral John Tovey, commanding British forces from King George V, ordered cessation of gunfire. The battleships were running low on fuel and ammunition. Bismarck was clearly defeated, but showed no signs of sinking quickly. Tovey ordered HMS Dorsetshire to finish Bismarck with torpedoes. Dorsetshire fired 3 torpedoes from starboard side, 2 hit. Dorsetshire then crossed to port side and fired one torpedo. This also hit. Total torpedo hits: 3 confirmed, possibly 4. Even with torpedo hits, Bismarck remained afloat. However, at 10:36 hours, the ship suddenly rolled to port and capsized. The hull remained visible briefly before sinking by the stern. Bismarck disappeared beneath the surface at 10:39 hours at position 48 degrees or N 16 degrees 12 WW, approximately 640 kilometers west of Brest, France. Water depth at sinking location, approximately 4,190 meters. Of Bismarck's crew of 2,065 officers and men, approximately 1,950 died. The exact number killed during the battle versus drowning after sinking is uncertain. Most casualties occurred during the final battle or from drowning in the subsequent sinking. British ships rescued 110 survivors, HMS Dorsetshire, 85 survivors, HMS Maori, destroyer, 25 survivors. An additional 5 survivors were rescued by German ships, U-74, submarine, 3 survivors Saxonwald, weather ship, 2 survivors, total survivors 115 men. The low survivor count resulted from several factors. British rescue operations were interrupted when U-boat warning was received, later determined false. Many survivors were left in the water and drowned. Water temperature was approximately 4 degrees Celsius. Survival time in water was less than 30 minutes for most individuals. Survivors had to abandon ship without life rafts or adequate survival equipment. British casualties during the pursuit were minimal. HMS Hood, 1,415 dead, May 24. HMS Prince of Wales, 7 dead, May 24. Aircraft losses: 4 Swordfish aircraft destroyed during operations. Total British dead: approximately 1,422 British naval officers were puzzled by Bismarck's resistance to sinking. Over 700 main battery shells had hit the ship. Multiple torpedoes had struck. The engagement lasted 90 minutes at point-blank range, yet Bismarck had not sunk from British gunfire alone. The ship remained afloat until either torpedo damage or scuttling caused final sinking. Initial British analysis concluded that Bismarck's armor protection had been exceptionally effective. The armor belt had resisted penetration from most shells. The internal subdivision had prevented flooding from spreading throughout the ship. The underwater protection had absorbed torpedo hits without catastrophic failure. However, precise details of how the ship sank remained uncertain. British observers reported that Bismarck appeared to capsize rather than sinking from progressive flooding. This suggested possible scuttling by the German crew rather than sinking from British weapons. German survivors provided conflicting accounts. Some reported receiving orders to open seacocks and flood the ship to prevent capture. Others reported no such orders and suggested the ship sank from battle damage. The confusion during the final minutes made determining the exact sequence of events difficult. On June 8, 1989, oceanographer Robert Ballard located Bismarck's wreck using sonar equipment aboard the research vessel Starella. Ballard had previously discovered the wreck of RMS Titanic in 1985 and possessed extensive experience in deep-sea exploration. The wreck was located at position 48 dig 10 AN 16 dig 12 OW at depth of 4,190 meters, 15,116 feet. The position matched the reported sinking location from 1941. The wreck lies upright on the seabed. The hull is largely intact, though the superstructure was destroyed during the battle. The bow separated from the main hull during descent and lies approximately 1 kilometer away. The stern section remains attached. Ballard's expedition examined the wreck using remotely operated vehicles, ROVs, equipped with cameras and sonar. The examination revealed several significant findings. Hull integrity. The armored citadel, the central portion containing machinery and magazines, showed remarkably little penetration damage. While the upper works were destroyed, the main armor belt showed few penetrations. Most British shells had failed to penetrate the 320mm belt armor. Torpedo damage. Evidence of torpedo hits was observed, but the damage was not catastrophic. The underwater protection system had functioned largely as designed. Torpedo explosions had breached the outer hull, but had not penetrated the inner hull in most locations. Bottom damage. The hull showed damage along the bottom, consistent with hitting the seabed at high velocity. The ship had fallen nearly 5,000 meters and struck the bottom with considerable force. This impact damage made determining the exact cause of sinking more difficult. Scuttling evidence. The ROV examination found that several internal bulkheads appeared to have collapsed outward rather than inward. This is consistent with internal flooding through opened seacocks rather than external breach. Additionally, seacocks in examined compartments appeared to be in open position. These findings supported the theory that the German crew had scuttled the ship. Ballard's preliminary conclusion was that British gunfire had destroyed Bismarck as a fighting unit by eliminating the crew and weapon systems, but had not penetrated the armoured citadel deeply enough to cause rapid sinking through flooding. The German crew had likely opened seacocks to scuttle the ship and prevent capture. Even if scuttling had not occurred, progressive flooding from accumulated damage would eventually have sunk the ship, but this might have taken hours rather than minutes. Subsequent analysis by naval architects and engineers examined why Bismarck's armour proved so resistant to British gunfire. Several factors contributed. Armour quality. German Krupp cemented armour was approximately 10 ton of 15% harder and more resistant than British armour. The face-hardening process created extremely hard surface that could shatter armour-piercing caps on shells. The tough backing prevented the armour plate itself from shattering. This combination made German armour superior to equivalent thickness armour from other nations. Armour inclination. Bismarck's belt armour was inclined at 20 degrees from vertical. This increased effective thickness by approximately 6%. More importantly, the inclination increased the probability of shells deflecting rather than penetrating. Shells striking at oblique angles would more likely ricochet off the inclined armour. Range effects. During the final battle, British ships closed to 8,000–12,000 meters. At these ranges, shells struck Bismarck's armour at relatively flat angles. The shells were not falling from high arcs, they were flying on relatively flat trajectories. This meant shells struck the side armour rather than deck armour. Bismarck's side armour was much thicker than deck armour. The engagement range actually favoured Bismarck's armour scheme. Shell performance. British 356mm and 406mm armour-piercing shells were designed to penetrate and then explode inside the target. However, hitting very hard armour at flat angles sometimes caused the shell's cap to shatter without achieving penetration. The shells would then explode outside the armour rather than inside. This reduced effectiveness. Compartmentalization. Even when shells did penetrate the armour belt, internal compartmentalization limited damage. Shells exploding in one compartment would not spread damage to adjacent compartments if watertight doors were closed. The crew had properly sealed compartments, preventing progressive flooding. Citadel design. The vital spaces, machinery, magazines, steering, were concentrated in the central citadel, which had maximum armour protection. Damage to bow and stern areas did not directly threaten these vital spaces. British shells destroyed large portions of the ship's ends but could not reach the protected citadel. The combination of these factors meant that Bismarck could absorb tremendous damage to non-vital areas, while the vital areas remained protected. British gunfire destroyed everything above the waterline and eliminated the ship's combat capability, but could not penetrate deeply enough to cause rapid sinking through flooding of vital spaces. Bismarck's final battle influenced naval architecture and tactics in several ways. Armour protection. The effectiveness of Bismarck's armour validated the German design philosophy of maximum protection for vital areas. Post-war battleship designs, though few were built, emphasized similar protection schemes. The U.S. Iowa-class battleships, designed during World War II, incorporated inclined belt armour similar to German practice. Torpedo warfare. The difficulty of sinking Bismarck with gunfire reinforced the importance of torpedoes for defeating heavily armoured ships. Torpedoes striking below the waterline could bypass thick side armour. The fatal damage to Bismarck came from the torpedo hit to the rudder rather than shell hits. Aircraft carriers. The role of aircraft carriers in tracking and attacking Bismarck demonstrated the changing nature of naval warfare. Swordfish aircraft from Ark Royal delivered the decisive torpedo hit that immobilized Bismarck. This foreshadowed the carrier's emergence as the dominant naval weapon system. Radar technology: British radar-equipped cruisers maintained contact with Bismarck even when visual observation was impossible. Radar allowed tracking through night and poor weather. This technological advantage proved decisive in preventing Bismarck's escape. Commerce raiding: Bismarck's operation demonstrated that battleship commerce raiding was no longer a viable strategy. The operation achieved tactical success, destruction of Hood, but strategic failure. Bismarck sunk before reaching convoy routes. Surface raiders could not operate effectively against coordinated opposition with radar, aircraft, and superior numbers. The Bismarck demonstrated that excellent armor protection could allow a battleship to survive massive punishment. However, survival was not equivalent to mission success. Bismarck could not sink from gunfire alone, but was rendered helpless and eventually destroyed. The final lesson was that even the best protected ship could not overcome numerical and technological superiority. The German battleship Bismarck represented the peak of armored battleship design. The ship's protection system was arguably the most effective ever installed on a battleship. The combination of thick Krupp-cemented armor, inclined belt placement, comprehensive compartmentalization, and sophisticated underwater protection created a vessel that could absorb extraordinary damage. During the final battle on May 27, 1941, British forces fired over 400 large-caliber shells at Bismarck from battleships, plus hundreds more from cruisers. Multiple torpedoes hit the ship. This concentrated firepower destroyed Bismarck as a fighting unit by eliminating the superstructure, weapons, and crew. However, the armored citadel remained largely intact. British weapons had destroyed the ship's combat capability, but had not penetrated the vital spaces sufficiently to cause rapid sinking through flooding. The examination of Bismarck's wreck in 1989 confirmed that the hull had largely survived the battle. The armor belt showed few penetrations. The underwater protection system had absorbed torpedo hits. The evidence suggested that scuttling by the German crew contributed to the final sinking, though accumulated damage would eventually have caused sinking regardless. Bismarck's sortie lasted 9 days from departure on May 18th to sinking on May 27th. The ship destroyed HMS Hood in approximately 10 minutes during the only surface engagement. British forces required 3 days of pursuit and the deployment of a large portion of the home fleet to locate and destroy Bismarck. The final battle lasted 90 minutes and required over 700 main battery shells to eliminate Bismarck as a fighting unit. The question of why 400 shells could not sink. Bismarck has a clear answer. The engineering of the armor protection system was exceptionally effective at resisting shell penetration into vital spaces. The armor performed exactly as designed. British gunfire destroyed non-protected areas but could not penetrate the protected citadel sufficiently to cause catastrophic flooding. The ship ultimately sank from accumulated damage and probable scuttling, rather than from any single British weapon achieving decisive penetration. This outcome validated German armor design, but did not translate to strategic success. Bismarck's excellent protection allowed survival under fire, but could not overcome Britain's advantages in numbers, radar, aircraft, and strategic position. The ship demonstrated that armor technology had reached high level of effectiveness by 1941, but also demonstrated that protection alone could not guarantee mission success or ship survival in modern naval warfare.